So welcome to Everyday Mathematics. So today we go to the last problem, problem number 5 of the 2025 MIT Integration B final. And that is the definite integral from x equals to 0 to x equals to 1 of the square root of 1 over 4x squared plus 1 over x minus the square root of x to the power 4 over 4 minus x plus 1 minus 1 over 2x. So looks a little bit intimidating, but let's see how we may be able to solve it. So this is our problem, and one thing that is telling is I look at 4x squared here, and I see 2x here. So I would like to create a common denominator on this side, and this is what I've done here, such that now when I have the 2x at the very end here, I'd like to combine these together. So we have now a definite integral from x equals to 0 to 1 of the square root of 1 plus 4x minus 4x cubed minus 1 over 2x minus the square root of x to the power 4 minus 4x plus 4 to the power over 2. So since this x to the power 4 is out there, let me try and see if I can substitute for this integrand here. So I'll say let u be equal to this guy, the square root of 1 plus 4x minus 4x cubed minus 1 over 2x, such that when I multiply 2x both the right and both the right and left hand side, I have 2xu being equal to the square root of 1 plus 4x minus 4x cubed minus 1. And then when I add 1 both sides, I have 2xu plus 1 equals to the square root of 1 plus 4x minus 4x cubed. If I square both the left and right hand side, that allows us to now get 4x squared u squared plus 4xu plus 1 equals to 1 plus 4x minus 4x cubed. Now this 1 and this 1 would cancel each other, so we have 4x squared u squared plus 4xu equals to 4x minus 4x cubed. What about if we divide both sides by 4x? So we are left with xu squared plus u equals to 1 minus x squared. So let's try to make x the subject, because we do have a quadratic equation here. So x is equals to negative u squared over 2 plus minus square root of u plus 4, u to the power 4 minus 4 times u minus 1 all over 2. But x lies between 0 and 1, right? So in some way x has to be positive. Since this is a square, x can only be possible if we take the plus sign here. So we're going to choose that x is equals to negative u squared over 2 plus the square root of u to the power 4 minus 4u plus 4 over 2, right? So with that being something that we know now, if we take the assumption that fx is our function of choice here, we can see that our inverse function is equal to this guy, but now we have x here minus x squared over 2, such that the inverse function of fx, the inverse function of fx plus x squared equals to the square root of x to the power 4 minus 4x plus 4 over 2. So that now our integral here is just the integral of fx, this guy here, from x equals to 0 to 1, minus the inverse function of fx minus x squared. We would like to separate this into three separate integrals, right? And then I would color code them so that now we do have the blue, we have the green, and then we have the white. So my main goal from here is to figure out how the integral of the inverse function of fx relates to the integral of fx. So now we do have this integral here, and obviously our focus now going forward is to see how the integral from x equals to 0 to x equals to 1 of the inverse function of fx is in regard to the integral of fx. So let's say y is equal to the inverse of the function fx, such that fy is equals to x, and that means that dx dy equals to the derivative of the function fy, and that means that we can substitute for dx with the integral of y, the function, the derivative of fy times dy. When x equals to 0, what is y? We have y being equal to the inverse function of 0. And since we knew that the inverse function of fx is x to the power 4 minus 4x plus 1. When we substitute 0 plus 4 over 2 minus 0 x squared over 2, and substitute 0 in place of x, we just get 1 here. When x equals to 1, we do the same, and we find that it's 0. So the integral here now becomes where it's 0, we have 1, where x is 1, we have 0. And then in place of this guy, we have y here. And in place of this guy here, we have derivative of fy times dy from this expression. And now we're going to use integration by parts, where you have if you have a product of v and the derivative of u, the product of u and v is the first integral here, minus the derivative of y, which is 1 times u. So we've used integration by parts here. And we can see here, since we have a negative sign, we can flip the limits, and we change this negative to a positive sign. Right? So let's continue. So now that we have this guy here, we can go back and substitute for y. We know fy is 1 plus 4y minus 4 cube square root of minus 1 over 2y. This y's cancel, and that means that we do have square root of 1 plus 4y minus 4 cube minus 1 over 2, and that integral remains there. When y is equal to 0, this guy goes to 0, and y is equal to 1, this guy goes to 0. So this entire enterprise goes to 0, and that means that the integral of the inverse function of fx from x equals to 0 to 1 is just the same as the same integral of x from 0 to 1. And so that's important for us, because now we can say that this original integral we had is the same thing, and these two integrals cancel out, and we're left with the negative of the integral from x equals to 0 to 1 of x squared over 2, which is negative of x cubed over 6 with limit 0 and 1. And that means we have negative 1 over 6 as our answer. So that is the much of it. We do encourage you, if you haven't subscribed to our channel, please subscribe to our channel. If you also like our video, that will help us a lot. But all the same, thank you so much for joining us at Everyday Mathematics today. Have a blessed day ahead, and it was great hanging out with you. Bye bye.